Moisture content problem. Geotechnical laboratory testing of a soil sample requires a moisture content change. The soil specimen has a mass of 1.8 kilograms and has a moisture content of 6%. What is the mass or volume of water required to change the moisture content from 6% to 11%, which is a 5% increase in moisture content? So that essentially we want to change from a initial moisture content state to a final water content state. So we know our initial soil sample is 1.8 kilograms. So let's call it M1. M1 equals to 1.8 kilograms. Our initial water content is 6%. So let's call it W1 for initial water content. 6% is 0.06. Their final water content, the one we want to aim for, is 11%. Let's call it W2, 11%, 0.11. And delta W, or the change in water content, is 0.05. So let's start with the definition of water content. So W equals the mass of water in the soil sample over the mass of solids in the soil sample. So mass of all the solid and hard particles, anything that's solid. And we can call this MW, M subscript W over M subscript S. So let's rearrange this for solving for MW. So we get water content times mass of solids. Then for our soil sample, we could say that it's made up of water, MW, plus the solid particles. So the mass of the total soil sample is its water and its solid particles. In geotechnical analysis or soil mechanics, there's also an air term here, mass of the air, but it's so close to zero, we could just neglect it. Okay, now we can sub in our MW from this into our MW for M1. So technically the MW here is actually MW1 because the water content is a variable that will change, whereas the mass of the solids is a constant through the whole problem. So we get MWS. So W initial times mass of solids plus mass of solids. We know mass of initial mass of the sample, and we know the initial water content. So let's solve for MS. So MS. So we factor out MS, we get W1 plus 1, and we divide W initial water content plus 1. Yeah, that's what we do, and we get soil sample over moisture content plus 1. Sub in our values, 1.8 kilograms, 0.06 plus 1. And we'll get 1.698 kilograms. That is the mass of our solids. Okay, we can use the same equation to find the final soil sample mass. We can call it MW2 plus MS, which is water content times mass of solids plus mass of solids. This time we don't need to solve for mass of solids because we solved for it in the problem above. So we just need to get what the mass of the second sample is, or the final sample. We're given W2 up here, so it's 0.11 times 1.698 kilograms plus 1.698 kilograms. And we'll get 1.885 kilograms. So now that we have our final mass and our initial mass, we could say that the Final mass is basically just the initial plus a change in mass. And we will assume that this change in mass is due to water. It's just due to the moisture content change. So our solid particles mass or solid particles is constant. Okay? So let's solve for delta M, which will be delta M equals to M2 minus M1. Sub in our values for it. M2 is 1.885 kilograms minus M1, which is 1.8 kilograms. We will get 0.085 kilograms. So this change in mass is only due to water. So this is the water mass of water required to change our moisture content from 6 to 11%. And if we solve using our density equation, which is mass over volume, we know the volume required is just going to become delta M over density of water, which is 0.085 kilograms, over the density of water, which is a constant of 1,000 kilograms per meters cubed. Easiest number to remember, and we get 0.0000085 meters cubed, or we get 0.0000085 liters, and that is just, wait, that is not correct. And then that is 0.085 liters, which is just 85 milliliters. So that is the volume of water required to change our moisture content from 6% to 11%, which is just the 5% increase in moisture content.